Good morning, everyone. So, in the previous class, we have seen about the EC2 storage thing. So, what are the different types of storages that are available in EC2? And today we are going to see an important topic, okay, which is called like a EC2 Elastic Load Balancer. Okay, so elastic load balancers is one of the strongest feature in EC2. So it's being like all the EC2 instances which are being created, so they can be connected to a EC2 elastic load balancer. So this helps a lot in the real time to run your applications with high availability and scalability. Okay, so first we'll go with some theory part. So just we'll see some concepts and then we'll go to the hands-on part on how to create a load balancer and how we'll use it. So before knowing about the EC2, you need to know about two things, that is scalability and high availability. Okay, scalability means that an application or system can handle the great loads by adapting. So your application must be adaptable to handle high loads and high requests. Okay, so there are two kinds of scalabilities. So one is vertical and second one is horizontal scalability. The horizontal scalability is something which we call as elasticity. Okay, scalability is also linked to high availability, but it is different from high availability. So to achieve high availability, we will be using this scalability. So high availability is something different from scalability. So we'll also see about how it works. And so for now, you remember like scalability is linked, but it is different to high availability. Okay, so scalability is something which you want to. So whenever your applications want to expand somehow, so you started with a like 100 or 1000 users application. So now your application is getting hits from almost 1 lakh users. So without changing the application, you need to scale the environment to run your application. Okay, so that is called scalability. Okay, so let's take an example here. So we'll see about what is vertical scalability. So vertical scalability means increasing the size of the instance or the servers. For example, say your application is running on T2 micro. Okay, so scaling that application vertically means the application is running on T2 large. Okay, so for example, say like there is a person called junior operator. So we'll take a example of a call center. So we have a junior operator who can attend 5 calls at a time. Okay, so so what happens is now my business got expanded and like I am getting a lot of calls and my uh, calls rate is increasing. So what I can do is I can recruit a senior operator who is able to attend 50 calls per second or 50 calls per day. Okay, so this is called vertical scalability. So this is here like if you compare, so in the initially like we are getting like 100 to 1000 requests. So then our small server is able to capture that and it is able to process the requests. So what happens is when your application has expanded and it has it got large number of users, so and you are getting 1000 requests per second. So what happens is more than 1000 requests per second. So what happens is you need to increase the size of the server, so that automatically increases the capability of the server, and this particular server will be able to receive more requests and process them compared to the old server. So this is the way like you can increase the server and you can increase the scalability of your applications. So increasing these servers or increasing the configuration of the servers of your applications is called vertical scaling or vertical scalability. Okay, so vertical scalability where we use is like we use them in a non-distributed system. So that means all your requests must be going to one server. Okay, such as databases. Okay, so this particular point you need to remember, vertical scalability is very common for non-distributed systems. So you need to highlight this non-distributed systems. Non-distributed systems are something like we cannot distribute and run them in different servers, so those will be running in the same server, so they are not distributed. So in such cases, we can use this vertical scalability and increase the servers. Okay, so non-distributed systems, so like a database are best example for non-distributed systems. Okay, so where we can use is like RDS, elastic cache charger services that can scale vertically. So RDS is like relational database service which is being provided by the AWS itself. So this is also a database that is provided by AWS. So RDS, this particular RDS, all the services are best example services that can be scaled vertically. So there's usually a limit like how much you can vertically scale. So that means there is a hardware limit. So there is a hardware limit in AWS. So which is mostly sufficient for us, but there is a limit. Okay. So we need to understand that. So coming to the horizontal scaling. So horizontal scaling means increasing the number of instances of your application. So instead of changing the application from small server to big server, what we will do is we will add another same server. So say like in the previous example only. So say like we have the junior operator who can handle 5 calls. Similarly, so when I got more calls, I can recruit and another other same operator who can handle another 5 calls. So if that still increases, I can like recruit another operator. So if there are more calls, I can recruit like another 3 operators. So what happens is here we are increasing the servers instead of increasing the server's configuration. So we are not replacing this old server with a new server. What we are doing is we are keeping the same servers and we are multiplying the servers. Okay, so horizontal scale employs distributed systems. So here it is for the distributed systems. Vertical scaling is for non-distributed systems and horizontal scaling is for distributed systems. So this is very common for web application and modern applications. Okay, so it is easy to horizontally scale with the AWS cloud offering such services to call AWS EC2. Okay, so this all the services, there's a services called load balancing in AWS EC2, and this particular horizontal scaling can be achieved easily through AWS EC2. So we don't need to put any other hardware or something. So we don't need to do any other servers or something. So there is also a predefined service for this to scale this horizontally in EC2. Okay. And coming to high availability. So in the previous slide we have seen about the scalability. So now we want to see, we'll see like what is high availability. So high availability usually goes hand in hand with horizontal scaling. So this high availability is something which can be achieved using the horizontal scaling. So high availability means running your applications or your system, okay, in at least like 2 data centers. So that means 2 availability zones. For example, the goal of the high availability is to make your data center, make your application survive if there is still any data center loss. Okay, so the high availability can be passive for RDS and multi availability zone, for example, and the high availability can be active for horizontal scaling. Okay, so let's take an example. So in the previous example, we have like 6 different operators who are attending the calls. Okay, and those 6 are horizontally scaling. So we are using this horizontal scaling for high availability. So what happens is if I keep this all 6 employees in one building in New York, for example, if I kept all of them in New York, so if there is any power issue in the New York building, so what happens is, so all the connectivity, all the work that the 6 people need to do will be stopped. So there won't be available. These 6 people will not be available, and we cannot achieve high availability. So instead of that, what we do is, so we keep 3 employees in our New York building, New York building, and other 3 employees in my other branch calls in San Francisco. So for example, this is in New York availability zone and this is San Francisco availability zone. So if I am keeping these 3 employees in three employees in different availability zones, what happens is, so if anything goes wrong in my first availability zone, still I have 3 employees who are working in another availability zone. So I can transfer the calls to this particular office. Okay, if this office goes down or any power issues comes in this office, and then I can send my request to this particular office. So in both cases I am transferring these calls to any other services instead of stopping them. So so here what we are having is, here we have high availability, so that my particular call center will not goes down in any case. So only thing is, when this power goes in both of them, so then only it happens, and that happens very rarely, right? So this is called high availability. So high availability is nothing but making your application, okay, available to use, okay, 24/7 without any, okay, downtime. Okay, so scalability is something which is used to scale your application, so expand your application. High availability is something which is making your application available without any, okay, downtime. So this is the difference between, okay, scalability and high availability. But to avail high availability, see here we are using horizontal scaling. That means we are using different type servers. So to achieve high availability, we are using scalability, but this is different from high availability and scalability. Okay, so some more points about high availability and scalability for EC2. So in vertical scaling, coming about vertical scaling, increasing the size of the server. So we have seen, so vertical scaling can be achieved increasing the size of the servers. So in EC2 we have, like, the least server is T2 Nano, which has 0.5 GB of RAM and one CPU, one core CPU, and the highest instance we are having is this one, which has 12.3 terabytes of RAM and 444 core CPU. See, this is a pretty huge server, and in between them we have different types of servers, like hundreds of servers in between them. So you can choose any of these instances, so, and you can achieve the vertical scaling. Okay, so horizontal scaling is something, so you are increasing the number of instances. So this can be achieved using auto scaling groups and load balancers. So we are going to see this in detail in our coming classes. So just remember, horizontal scaling, to achieve horizontal scaling in EC2, we will be using like auto scaling groups and load balancers. Okay, so in AWS terminology, if you are increasing the servers, then we are saying it as scale out, and if you are removing the servers or decreasing the servers, we are calling it as scale in. Okay, so if you in the coming classes, if you hear anything like scale out and scaling, that means scale out means like we are increasing the servers, scale in means we are decreasing the servers count. Okay, so coming to high availability, so run instance for the same application across multiple availability zone. So to make it available, so we are running it in multiple availability zones. So this can be done using auto scaling group in multi-AZ and load balancers in multi-AZ. Okay, so similar to this, but we are doing it in multiple availability zones to achieve them in high scale, to achieve high availability. So this is for this 2 is for scaling, and this is for the availability. Okay, so let's see what is a load balancing. So here we are using something called load balancer to horizontally scale. So horizontal scale is something where we are increasing the servers. So what is this load balancer? Okay, so load balancers are servers that forward traffic to multiple servers. So for example, our EC2 instances. Okay, so these servers are EC2 instances. Say like we have one employee, so we have one user, so he is requesting, he is putting a request, or he is sending a request, that may be a HTTP request, and it goes to the load balancer, and the load balancer will send it to one server. So this is like what we have seen is this horizontal scalability, we are increasing the servers. So for our application we have kept 3 servers, and in these 3 servers, consider like our application is running in these 3 servers. Okay, so these are the different users who are using our application. So whenever the first user is like requesting a request, so then it go to load balancer, and the load balancer will forward that request to EC2 instance, and it will get a response, and so send this response to him. And at the same time, if another user is also requesting, So what it will do is, as the first service is already serving the first person, it will send the request to the second instance, and the second instance is giving the response to the load balancer, and the load balancer will send this response to the second user. Okay, and at the same time a third person is also doing the same request. So what happens is, as these two servers are already serving these two persons, okay, the load balancer will send excuse me, the request to the third server, and it gets the response from him, and it sends the response to the third person. Similarly, so if there are number of users who are using your applications, it will take the load, and based on the servers which are serving and which are free, it will send the requests to the EC2 instance, and it will balance the load between these three instances and the application. So overall your applications, so the particular persons will not know from which server I am getting this request or something. So he just give a response, just gives a request and gets the response. But these three persons, or the persons who are using this application, will not know like how many servers are in the like backend, so how many servers are serving to get my response. Okay, they don't know anything. So everything, so load balancer will be handling them. Okay, so that is called load balancer. Load balancer is something which balances the load, as the name says itself. It balances the load which is coming inside the server's load. So inward traffic. So it takes inward traffic and balances the load. So based on sending the request to the free EC2 instance and gives the response. So in such way, like it balances the load which is coming inward. Okay, so why we are using load balancer? So it spread across multiple downstream instances, so expose a single point access DNS to your applications. That means you will get a DNS for particular EC2. So DNS is something like a public IP. Okay, so we will be getting a DNS address for our load balancer. So with that load balancer we can send requests to all these instances. Okay, and we have a seamlessly handle failure of downstream instances and do regular health checkups to your instances. So if any say like here we have three instances. If there is any issue happened in this EC2 instance, and in some cases, like due to some cases my application went down or this instance get down, so what happens is it removes the particular server from the load balancer. Excuse me. Okay, what happens is it removes this instance from the load balancer, and it only sends the load to these two instances. Okay, so this is how it maintains the health checkup to EC2 all these servers which are connected to it. And if any of these health checks fail, so that any instance goes down, it will pull out this instance from this load balancer, and it transfers the load to only other two EC2 instances. So this is called health checkups, and it provides SSL terminations also for the websites, and it enforces the stickiness with cookies. So we'll see about the stickiness in the coming classes. So, and high availability, so this is the main reason we are using this load balancer. It provides the high availability across zones, and we'll also get a separate public traffic from private traffic. Okay, so these are the reasons why we are using load balancers. So, and at some point we need to see why you are using load balancers is, so an elastic load balancer is a manager load balancer. That means like we can manage it using our AWS EC2 console. Okay, AWS guarantees that it will be working. So all the things, like we will just configure it, but the things which need to be configured for running it and the maintenance of this load balancer, all this the AWS will take care. So AWS take care for its upgrade, maintenance and high availability. So there is there is nothing like other things we need to go and maintain for this load balancer. So everything that AWS will take care, we just need to create one, that's it. AWS provide only few configuration knobs. So as I said, we just do some few configuration knobs, and rest other things the AWS handle the maintenance and all. Okay, so it costs less to set up your own load balancer, but it will be a lot more effort to our end. So if you want to create a load balancer using an other server, so that will take a lot of setup like for us, and maintenance also for us. So instead of doing that, we'll go with the load balancer, because if we create our own load balancer, it will cost us a more. And other best thing with the AWS load balancer is it is integrated with many AWS services. So there are like many services which are already available in EC2. So EC2 and AWS. So this EC2 load balancer that can be linked to other services also. So something like EC2 auto scaling groups and Amazon ECS. Okay, so we can be using other services, and we can integrate this other services to this particular load balancer, as it is also a AWS service. Okay, so we can add our manager certificates to your EC2 load balancer. That means like you can also allow only HTTPS traffic. So that means like we can add our certificate. So instead of using an outside HTTPS certificate, we can integrate the AWS load balancer with certificate manager in AWS, and we can attach a HTTPS certificate to our load balancer. So that is like that is more easy than when compare like you buying your own certificate and adding it to a load balancer is more complicated. Okay, so and we can connect it to route 3. So and this is also, we'll see all these services in our coming classes, but we can just remember this AWS load balancer, EC2 load balancer, can be integrated with other EC2 or other AWS services. Okay, so here we have seen about health checks, right? So what are health checks means? So health checks are crucial for load balancers. They enable the load balancers to know if the instance forwards traffic to are available to reply request. That means like it will check about the EC2 instance health. So that means it will ping like every second to this EC2 instance and see like whether it is giving response and is it available or stopped. So if the instance is stopped, or if the application inside it which we are running is stopped, what happens is this health checks will be failed. Okay, so if the health check fails, then it will remove this particular instance from the load balancer, and it won't send any request to this EC2 instance. The health check is done on a port or a route. So if you are running your application say like in a 80 port, so it will check for that port, or like if the port is like 4, 5, 6, 7, we can check in this particular port where your application is running. So if the application is not running, then this port will be closed. Okay, so if the port closed and if it is unable to connect to your EC2 instance from this port, then it will remove it. Or it can be configured on a particular route. Say like in your application you have defined a route like /health. So something in our Angular we have created some routes like /register, /health, /register, /login, and /home, right? Similarly, you can create a endpoint or a route which is called /health, and whenever you call that /health, if the application is responding and if it is giving some page or something, then the health checks will be passed. So if the application is down, okay, and it is calling /health route and it is not getting any response, okay, from the EC2 instance, then what it will do is it will remove this instance from the load balancer. Okay, so if the response code is 200, then it says like the instance is healthy or it is unhealthy. Okay, so we saw this particular response in our HTTP calls during Node.js API. Like whenever you request a call to a server, and if you get a response like 200 in your browser, so that means the particular server is responding and the request is success. Okay, so if the health check got if the health check did not get a 200 response, okay, when it do any health check with the path like /health or something, then it will mark this EC2 instance as unhealthy and it will remove it from the load balancer. Okay, so these are how these health checks will be used. We'll be seeing it in the hands-on today only, so don't worry about it. Just try to understand. So you'll get a high-level idea now. So, but when we go to a hands-on part, like you will understand it clearly. Okay. So now there are different types of load balancers in AWS. Okay, so we are talking about AWS and how the load balancer works, and how the EC2 load balancers are connected to like health checks. So what are the uses and what are the use cases where we use health checks we have seen, or the load balancer we have seen. Now we'll see like what are the different load balancers that are available in AWS. In AWS we have four kind of like managed load balancers. That means like you can configure them and manage them using AWS console. Okay, the first thing is classic load balancer. So this is the first generation load balancers which are like started in 2009, but now like AWS is like deprecating this. They are stopping this. They are still available in AWS console, but AWS itself says that this classic load balancers will be deprecated and they will be stopped in coming days, so don't use this. Okay, so they are mainly used for HTTP traffic, HTTPS traffic, and TCP and SSL traffics. Okay, so all these types of requests that can be handled by the classic load balancer. Okay, so other thing is application load balancer, which is a newer generation load balancer. So this is also useful for the HTTP traffic, HTTPS and WebSocket. So instead of using classic load balancer, now all the people are using application load balancers, as it is the latest one. Okay, similarly we have a network load balancer. So this is one of the highest highest configuration load balancer in AWS. So it is mostly used for the TCP and TLS and UDP connections. So these are so similarly like HTTP is a web protocol. Similarly we can send a traffic to our servers using these other ports, or okay, so using these protocols. So we can send the traffic to our EC2 instances in this particular protocol also. So these are mainly used for the IoT devices or the networking side. Instead of these application load balancers are something which are used for the websites and web applications, okay, and APIs. So, but this network load balancer is something which takes the data through IoT devices like fingerprint missions, GPS devices, okay, payment missions. So if you want to integrate those IoT devices to servers, then they will send this particular data in TCP or TLS or UDP protocols. Okay, so just remember this TCP. And there is another load balancer called gateway load balancers. These are mostly used in the network layer 3. So these are like used for the security purpose, and they have some firewalls or something. So based on the firewalls and based on the network rules which you have mentioned, so this gateway load balancers will be working. Okay, so overall it is recommended to use the newer generation load balancers as they provide more features. So we are not using the classic load balancer, that's why, because it is an old load balancer. So we will be using the newer load balancers. So some load balancers can be set up as internal or external. Okay, so we'll see that in the coming classes. So just forget about this last line. So here in this slide you need to understand like there are 4 different types of load balancers, and they handle different types of traffic, okay, which is coming into EC2 instances. Okay, so here we have a diagram, so how the load balancer security group works. So here we have seen we are attaching a security group to the EC2 instances. In our previous classes we have created EC2 instances and we have attached some security groups to EC2 instances. So here the load balancer itself also has a security groups. If you see in here, so this is the load balancer security groups. So we can define the traffic which is entering into the load balancer also. Similarly we have done in the EC2. So if you say I only allow HTTP and HTTPS calls only to my load balancer, so if you are using any load balancer, it will only allow that traffic. Okay, instead of like it checking for the EC2. Okay, so in the EC2 you may allow all the ports, but if you are using this EC2 instance through a load balancer, then So first it will check the security group of the load balancer, and then only it allows the traffic into this particular EC2 instance. Or you can also configure this EC2 this load balancer security group in EC2 instance, so that all the traffic which comes from load balancer only will be allowed to EC2. So this also we'll see on hands-on, so don't worry about this. And the first thing here you can see, this is the particular so the first table is the load balancer of this security group of this load balancer. So here we are allowing HTTP and HTTPS traffic, so from all the IPs, and in the bottom you can see the security group of this EC2 instance. So in this EC2 instance, what we are doing is, in the source part, instead of giving an IP address like this, instead of allowing all the IP, we are giving the another security group of the load balancer. So here what we are saying is, so in the source part we are giving the load balancer security group. So this security group we are defining here. That means we are saying to our EC2 instance that, so allow the traffic which is coming to my EC2 instance, that is from the load balancer only, so not from the any other IPs. Okay, instead of giving IP address or allowing through IP address or allowing the all, we are saying, so only allow the traffic which is coming from my load balancer. Okay, so we'll see how this works in the hands-on also, so don't worry about it. And coming to the first thing is a classic load balancer. So here it supports all the layers, so TCP, HTTP and all it will support, and it also support the health checks in TCP and HTTP based. So it is simple, like when you put a request from your client system, the classic load balancer receives it and it sends this request to EC2 instance. So it is straightforward. Okay, so you can just add a server and you can use this classic load balancer. So it is a simple way of configuration in the among all the load balancers. Okay, so but here like we are not using this classic load balancers now, because like they've been deprecated. Just to get an idea how it was, you need to understand this. So they will also get a fixed host name. So all these load balancers will get a fixed DNS name like this. With this DNS name we will be able to connect to this, send the request to this particular load balancer. Okay, so here we have another thing, application load balancer. So this is one of the important thing you need to learn, and we are also doing the hands-on on this application load balancer only. So application load balancer is a layer 7. So we know that there are different types of network layers. So this layer 7 is something like which is in the bottom part. Okay, so based on this layer 7 we are providing the application load balancer. Okay, so we can load balance to multiple HTTP applications across the missions using these target groups. We'll also create these target groups. Okay, so load balance to multiple applications in the same missions. Okay, so this is something about the containers and the Docker part. Okay, and supports for HTTP 2 and WebSocket. Okay, and supports redirecting from HTTP to HTTPS. We can also redirect our traffic from HTTP to HTTPS. So we'll all see in the application load balancer hands-on. So there are other things we are knowing about application load balancers. We have a route tables to different target groups. Okay, so routing based on path URL. So that means your application like example.com/users can go to one server. All the requests from in this URL will go to one server, and all the requests from example/host, this can be redirected to another server. Okay, so based on the path or the route which we get from the particular web application or something, or an API, we can redirect the requests to different servers. Okay, so other thing is we can route based on host name in the URL. So I can say like all my one.example.com request must go to this particular instance, and all the other .example.com request to other particular instance. So this we can fix this routing. So we can like route all the requests from one host name to one server and other host name to another server. So we can also do that using application load balancer. Okay, so route based on query string or headers. So here I have example.com/user ID 123 and order ID false. So if I get this same query if I get this query after my URL, I can redirect to different server. So if I get true, order equal to true, I can redirect it to different EC2 instance. So I can manage the traffic where it need to go using some rules. So all these particular things are called rules. So that's also we'll see in our coming class. So application load balancers are great to fit for microservices, container based applications. Okay, it also has a port mapping feature to redirect the dynamic port to ECS. So we'll see all about this in the coming classes. Okay, in comparison, so we need multiple. So if you want to achieve these particular things, so if you want to achieve this particular first scenario or second scenario or third scenario, so if you want to do it with a classic load balancer, we need to define multiple classic load balancers. Okay, so that means for this host name you need to do one classic load balancer, and for the other host name you need to create another classic load balancer. But using an application load balancer, you can use a single application load balancer and you can define some rules. Okay, and based on the rules the traffic will be routed to different EC2 instances or different servers. So for example, say here we have an application load balancer which is a web based HTTP based. Here like I am getting one request which is called which is ends with /user. So I can redirect all those /user requests to one target group, and in this target group we have different EC2 instances, and this target group also has a health check. If any EC2 instance health checks fail, so it will remove this EC2 instance from this target group. Okay, so if I have another URL called /search, then what happens is I will redirect it to different target group. So here we have another target group which is receiving the request from the load balancer which comes with the root /search. Okay, so these are mostly used in the microservices. So microservices is a different concept. So in the high level I want to explain you, like micro concept is you are dividing all your modules in your web applications into different different other small services, and you are deploying it in independent servers. Okay, so all the users related APIs and all the user related information will be in a different microservice. All the search related or the products related something will be in a different micro application. Okay, microservice. So based on the route you will redirect to that particular microservices running instances. Okay, we'll see another example here. So here we have a other example based on the query parameter. So say like I have an application. So for that application I have a desktop website and a mobile application. So what I want to do is I want to send the traffic which comes to the desktop application to one target group, and all the requests from the mobile app, so all the requests which are coming from the mobile app, I want to send it to another EC2 instances group. So what I can do is I can send like this. So in the every URL I will send a key called platform. If the platform is mobile, okay, so that particular request will go to this target group. So if the platform is desktop, so then that particular request will be goes to this target group. Okay, so based on the query parameters also we can distribute the traffic among different EC2 instances which are connected in a target group. Okay, so first we'll see. So it's enough, like we had a lot of theory part till now. So we'll go to the hands-on part now. So for this, first I'll go to my AWS management console. So here I have my AWS management console. So I am going to EC2 because load balancers are sub-services in EC2. So to do this, first I want to do a few things. So what I'll do is, so here I'm in my so here now I am in my EC2 dashboard. So I'll go to instances. So what I'll do is now I'll run two servers. So we need to balance the load across two server sides. So first I'll do is, so I'll go to launch instances. Okay, so here I'll give my web server name EC2 Load. instances. Okay, so here I am selecting my Amazon Linux only. So I'll take this T2, this is reader eligible, and proceed with the queue. So for this I am not using any key pair, so I'm not going to SSH into it anyway. So I'm going to select my existing launch wizard one. We have a default security group here, so that we have created in the previous classes. So I'll use this, I'll keep this same, and in the advanced settings, what I'll do, I'll go here and put that script where we can run this EC2 web server. So here I think I have kept that script. Okay, so here I have kept this. I'm taking this script. So while running, I'm running this data, user data. So you know what it is for, like we are installing a web server, and here we are running to see what is the host name, so in which host we are running, so this will print the host name, right? So okay, so everything is fine for my configuration, and with this configuration I will launch two servers. Okay, I launch two instances, which is with Amazon Linux, T2 micro, and my default security group, and which has with one volume, and we are running this user data in both of the instances, and I'll click on launch instances. So it is creating my instances. I'll go to this page, instances page. So they are getting ready. Meanwhile, we'll go to this security group and see what are the rules that are being allowed now. So this is my security group. So I go to my inbound rules. So here we are allowing the HTTP traffic and the SSH traffic to our both instances from any IP, right? So that's good. We'll go to our instances. We have one instance running. So now I have my both instances which are running. So I'll take this public IP, or we can also use this DNS, okay, instead of public IP. So I'll copy this and I'll try to run this. Okay, so I'm able to run my first instance. So a web server is running in my first instance, and here I have another one. So I'll run this also. Okay, so now my both servers are ready. So I want to use these two servers and create and link them to a load balancers. That means like I have these two servers running with my application. So I want to send the traffic, and I want to balance the traffic between the two servers. So I want my request to go to these two servers using a load balancer. So now we'll go to load balancers. Here we have load balancing option. So click on load balancers. So here click on create load balancer. So here you will see different options here. So what type of load balancer you want to create? Is it a application load balancer, network load balancer? Okay, so gateway load balancers. So if you can see this application load balancer, they are taking the HTTP and HTTPS traffic, and we are sending to different AWS services. That may be an EC2 instance, that may be a Lambda function or something. Okay, so coming to the network load balancers, so it is taking the requests from the web application or the VPC or some other devices or any IoT devices. It may send the traffic. Okay, so this take the traffic with these protocols, and the other thing is the traffic which you received from the network load balancer, they can be also sent to an application load balancer, and then from then they can send to any other EC2 service. So that means if you take this whole part and you can keep it here, so that means you can use a application load balancer also as a endpoint for this network load balancer. Okay, so this gateway load balancer is something which take the this traffic, and it checks the security and the firewall rules and all, and based on this particular rules it will be allowing the traffic inside the EC2 instances. Okay, so this is something, and here we can see this previous generation classic load balancer. So AWS is still showing it, but like they are saying it will be deprecated. So we have existing applications, so there may be already like some existing applications that are running in classic load balancer. So for that they are still showing this, but they are saying that this is a previous generation and don't use this. So if you want to create a new load balancer, then go with the application load balancer instead of classic. So now we are doing is like we are creating application load balancer. So click on create. So if you want to see like how it works, they'll provide some information here. You can just go through it, or else you can leave this. And here I'll give the load balancer name. Here I give my EC2 load balancer, and this is an elastic application load balancer. So I'll put this like ALB. Okay, so this is like internet facing. So we are putting our requests from, we are sending the request from the internet. So this particular load balancer should be internet facing. Okay, so and it will provide a IPv4 address, and here we need to define like to which particular availability zones this particular load balancer traffic must be sent. That means like we are creating a load balancer, and here we have created two instances in same availability zone, but I want to send the traffic across the EC2 instances which are in the different availability zones. That I need to select that availability zones. Okay, so say like if I want to run two servers in AP South 1A and 1B, and I want to send the traffic between the two servers. So that means if anything happens in my first availability zone, so still my second availability zone will be safe, and that request will be sent to this particular EC2 instance. So this is what we have seen in the previous slide, multiple AC. So here you have seen that, right? So see here like network, we can use it using different availability. We can share it across different availability zones. I have kept that in slides. Okay, just understand like we can achieve high availability also. In the high availability I think we have seen. So if you are using only one availability zone, this will all work, this will also work, but like this particular load balancer will show the instances only in this particular availability zone. So you can select the instances only in this particular availability zone, and you can select multiple only in this particular availability zone. So if you want to run your instances in different availability zones, and if you want to use those instances in the load balancer, you need to select so what the instances that you are trying to show or like use in this load balancer. So for now like I'm creating, so I am checking all these three. So I want to use all the availability zones. So here what we'll do is we'll create a new security group for this. So create a new security group. I'll create a new security group for my load balancer. So what I'll do is my ALB security group. Okay, so this allows all the HTTP traffic. Okay, so what I'll do is I'll create a new security group for my load balancer, and in inbound routes what I'll do is I'll allow all the HTTP traffic that is coming into my load balancer. So I'm allowing it from anywhere. So I have created it, and I'll save this group. So here we have security group, and it is allowing all the HTTP traffic. So I'll go to my here and I'll refresh this. So not this one. So this one. So I'll refresh this, and here I got my ALB security group. I'm using this, and I'll remove the previous one. So I have added a security group also. So if you want to, now this is one of the important part, like what we have to see in the application load balancer, and this will not be in the classic load balancer. So here we need to provide the listeners. So and here we need to define the routing here, and we need to create to which target group, this particular protocol data need to be sent. Here we see we are like, so for now what we'll do is like I'll send all my HTTP traffic which is coming on port 80, and to which I need to to which target group I need to forward it, I'll define it. So what this will do is, whenever a load balancer receives the data from port 80, it will redirect that data to this target group. So I'll create a target group. So target group is something which we use to like pair some instances. And so here, to create a target group, see, like I am creating a target group means that I am sending this data which I received from the load balancer to instances. So I want to redirect that data from load balancer to instance. So here I'll create a target group which targets the instances, and here the target group name is my HTTP web server, okay, target group. So here, so the protocol is also port 80 and it supports HTTP1, all this, and will leave all this like this, and a health check also I'll leave this, and here I'll create a target group. So we cannot give any spaces here, so we'll put an hyphen. So this is my web server, so target group. So here, after creating a target group, we need to register the instances which we want to put in the target group. So I am selecting these two instances and I'm including it. So I'll get all these instances here, and I'll create a target group which targets these two instances. So create it. So here in the target group, see, I have one target group created and it runs on port 80. It receives the port 80, and in this target group we have two targets. See here, we have two instances here. So as of now, it takes some time to attach it to the load balancer. So here we have the health checks. So health checks also we'll see about how they work. Okay, so it will take some time, I think. So we'll go back to our load balancer. So now we have created a target group. So if you refresh it, so now what I'm doing is, so whenever I get a traffic to load balancer on port 80, I am sending this traffic to this target group, and this target group consists of two EC2 instances. Okay, so we will get one request to the load balancer here, and that request will be sent to this target group, and based on the availability of the server, this target group will send a request to any of the server. Okay, so this is target groups, and that's it. We'll leave all this like this, and we'll create this load balancer. Okay, so we'll go to my load balancers here. So here we have created a load balancer. So if you go here, see here we have one load balancer. So when you click on this load balancer, you will get the details of this. So it is still in the provisioning state, so it is being created, and it is available in these 3 availability zones. Okay, and here we have the DNS name of the load balancer through which we are able to connect to this application load balancer. So we don't get any IPs here. So here we are running our EC2 instances directly with the IP. So when you are using the EC2 instances with the load balancer, when you want to send your a request to EC2 instances with the load balancer, we need to use this. Okay, so here we have this load balancer have one like rule. So we are sending all the HTTP 80 traffic to this particular target group. So we have only one rule in this. Okay, so if I go to this target group again, so now we'll see. So this is the target group. Here you can also go from here, so you can see the target groups here. So if when you click on this target group, so it is still initializing. So okay, see, now the health status is healthy. That means these two particular EC2 instances are connected to this target group, and these both are healthy, and they are healthy means they are ready to receive the requests. Okay, so this target group will send the request with among these two of this instances and will send the response back. Okay, so if you see here the target is like, so here see there are two instances healthy, there are two targets, and among the two are healthy, so everything is okay. So now we need to see our load balance is ready or not. Okay, so it is also in active state now, so my load balancer is also created. So what I'll do is, now I'll take this DNS, and here see we have two IP addresses like 110 and the other service running with 184. Okay, so what happens is, now if I go to this and if I run this load balancer URL, see now we got 184. So if I keep on running this and if I keep on refresh this, see my load is getting across these two servers. So I am only running my load balancer URL here. So but the load is going to, sometime it's going to one server and sometime it's going to other server. See, when I refresh it, it is going to, the requests are going to two servers and it is giving the response from the two servers. Okay, so this is how we set up a load balancer among different EC2 instances, and we can share the load. So now I am just hitting the refresh button and there will be a less load, but in the real-time applications they will get like 100 to 1000 or like 500 requests per second. For 1 second they will get 500 requests. Okay, at that time this load balancer will handle that load and it will send that load across the instances which are used for the horizontal scaling, and it will distribute the request among the servers which are configured in this target group, and it will share this. So say like if your application is still like having 1 lakh requests per second, it is getting 1 lakh requests per minute or second, and these two servers are not able to handle this still. So and these two servers which are on the target group is not able to handle. So then what we'll do is, we'll add another two more instances and we add the two instances to this target group. So then the load will be shared across this 4, and so we'll achieve maximum number of requests. Okay, so this is how the load balancer will work. So and other few things we'll see, anyway we have created it, we'll see some other things in this load balancer. So here we have a load balancer URL, and when you are running this, so you are able to get the response. And still if you go to your individual public IP addresses, so here also it is still getting requests and it is serving the requests. So what I want to do is, I don't want to allow the traffic directly to my EC2 instance with this public IP. So I only want to allow the traffic to my EC2 instance through the load balancer. Okay, so only my instance, all my EC2 instances should receive the request only from the load balancer, and I don't want them to run independently. So what we can do is, here first thing we'll go to the security groups, and this is the security group of our EC2 instance where we are along port 80 and 22. So here we'll go to our inbound rules and we'll edit our inbound rules. So here we are allowing the 80 port directly to all. Okay, so from anywhere we are allowing this 80 port. Instead of allowing it from other things, what we'll do is, all the IPs, here we can give a security group. So here these are the security groups. If you go down, so this is my security application load balancer security group. Okay, so I'll put this here. So I'll delete this and I'll create again another HTTP endpoint. So I'll put a anywhere. So here I'll give custom thing, not anywhere. So in the custom thing I'll give my application load balancer here, my application load balancer. Okay, so now what we are saying is, so allow the only allow the HTTP traffic that comes from this particular application load balancer only. So we'll save the rules. Okay, so we have attached this particular security group to both of our servers. So if you see my load balancer, still I am getting response from the EC2 instances. But if you go here and if you run this directly, see it is still loading and you are not able to get the response. So that means you cannot directly access this public IP, okay, and you cannot serve the requests which are coming to 80 port directly to this server with this public IP. So all the traffic will be going through this, only through this load balancer. Okay, so this is how we'll use the security group of load balancers in the EC2 instance. Okay, and other thing we need to see is, so here we have two instances in the target group. So let's go to my target group here. So here we have one target group and we have two instances in this. So these two instances are running and it is sharing the load across these two instances. What happens if any of these instances goes down? So let's see this. So I'm going to my instances, and here what I'll do is I'll stop this second instance. Okay, so that is my 184. So here I'm getting my load to 184 and 110, right? So what I'll do is I'll stop this 184 server. So I'll go to instance state and stop this. So now my instance went down, so it is getting stopped. So if I go to this target groups again and if I refresh this, so it still need to remove this from the. So this health checks, like how it will work is, so if you edit this, so what happens is, like, you can create a health check here. So in the advanced setting you can see, so if the health threshold is like for 5 times, okay, so for 5 times if we so how this works is, this particular health check will like continuously ping the EC2 instances, okay, and if the instance gives a success response, then it is okay, and if the instance gives any two in consecutive 2, so like if I am doing 5 requests to my EC2 instances, among that 5, if consecutively if the 2 requests are failed, then it will mark it as unhealthy and it removes the instance from this. So you can also set the interval, so with how many seconds interval you need to send the or ping the EC2 instances. So here we are sending the request for every 5 seconds. So for the 5 seconds, if the for every 30 seconds we are sending the request. So that means in the first 30 seconds, like if I have done a request now, okay, and it is success, and it will ping again in after 30 seconds and it will success, and again after 30 seconds, for every 30 seconds it will send this request. Say like in the first request it got failed, so that means the server went down and it didn't get any response. So again it will do another response, because we have defined 2. So in the second response also it didn't give any response. So what it will do is it will mark it as unhealthy. So we can define this here. Okay, so it takes like 1 minute, right? So in the first 30 seconds we will get one request, in the other 30 seconds we will get another request. If the 2 requests are failed, then it will mark as unhealthy, and again the instance got up, and if the instance got up and it got continuously 5 healthy 5 success response, then it will again mark the instance as healthy. So you can configure this, and you can also change the success code here. So this is something which we want to know in the professional level, but it's good to know here. So we'll go back, see, we'll go to my target groups, and here click on the target groups and refresh this. So now see here we have 2 target groups, among them one is healthy and one is unused. So that means the instance got stopped, and we are now only one particular EC2 instance is only available in this target group. So if I go to my EC2 load balancer here, see, so here I have stopped the this instance which is ends with 184, right? So now if I send request to this load balancer, see, now continuously it is serving only from 110. So it is not sending, the load balancer is not sending any requests to my 184 server, because the load balancer know that 184 server is not healthy and it is stopped and it cannot serve, so it is continuously sending to request to my this particular instance. In this case my application didn't went down, so but I am getting my application is serving well, but it is running in one server. So this is what we call high availability. So instead of stopping this applications, we are able to run this application. So my application didn't went down even if one server went down, so it is still up. So this is how we achieve high availability using horizontal scaling with load balancer. So this we need to understand. So this is how the load balancers works, and I want to show one more thing in this load balancers. So I'll go to load balancers here. I'll go to the target groups here. So here we have defined a target group, and here we have now we'll go to load balancer. When you click on the load balancer here in the listeners part, so here all the traffic which are getting from the 80 port, we are sending to this particular target group. So here we have something called rules, right? So when you click on this rules, so here in this rules, so we have one rule already created here. That means, so what that is doing is, so it is sending, if you click on this manage rules, so here we have all the rules for this application load balancer. So this is my application load balancer, and which is running on port 80. So here we have defined one target group. That means like we are sending all the requests to this target group. So this is one rule. So here what I can do is, so here we can define another target rule. So you can insert a rule. So here we have different conditions, and based on the different conditions to which EC2 service we need to forward this or redirect this. So for example, if I want to send this particular thing with path, so if I want to send all the requests which with error, so if the path is /error, that means, so if you after this particular URL, if you get anything like error, so you can define a rule. So I can add an action, and I can return a fixed response saying the response code is 403, and we can send something like server error 404 or something. You can add this. So whenever in this particular application load balancer, if you get anything like /error URL, so what it will do is it will redirect the response here. So I'll save this. So see, I have defined another rule here. So now I'll go here, and if I see /error, see, still it need to configure. I think it need to return error message. So similarly we can also add more rules. So if you want to send all the requests of particular hosts to particular actions, you can forward it or redirect it something. You can define these rules. Based on these rules, so the traffic which enters into this load balancer, and it will check all these rules. So if it is /error, it will take this route. So if there is any other condition, so if I want to give another host or something, so I can forward it to some other target group. So here I can create another target group. If my host is like admin.abc.com, I can redirect it to this particular another target group. I can create another target group, and I can redirect this to that. Similarly, so we can use these rules, and if I am getting a specific IP, so if I am getting request from a specific IP like 1.2.3.4, so only the request from this particular IP must go to a different target group. So you can define like that, or you can define it must be redirected to, if I am getting any request from this IP, I need to redirect it to some other particular URL or something. So I can give this here. So I can define a port of other thing. So we can define a particular like many number of rules, and based on these rules, so the traffic which comes into the application load balancers will choose its target group or choose its action. Okay, so that if that based on the rules, the traffic which entering into the load balancer will choose its action. Okay, so here I'll cancel this. So we have two rules here, /error. So I'll go through this and see if I run this here, see /error, it is returning a custom response here. Okay, so this is how we can do this. Okay, so this load balancer is something which we got in the free time for only for the short time. So after completing this particular hands-on, you need to remove all the instances and the load balancer. So quickly we'll see a small intro about the network load balancer also. So network load balancer also like works same as the application load balancer, but it has a security level. It works on the layer 4. That means application load balancer works on layer 7 in TCP, and it works on layer 4. So it is used to forward TCP and UDP traffic in your instances. In application load balancer we used HTTP and HTTPS, but in load balancer, network load balancer, it will handle the TCP and UDP. So it is one of the most efficient load balancer, and it can handle million requests per second. So, and it has a less latency, and mostly it take like 100 milliseconds to get the response. And when compared to application load balancer takes 400 milliseconds. That like it means like it is my 4 times faster than the application load balancer. Okay, so network load balancer also can get a static IP. So in the application load balancer we only get the DNS name, but we won't get any IP here. So we only get the DNS name to access this. Okay, so here we will only get DNS name. Okay, but in network load balancer we can get a static IP. So okay, it is used for the whitelisting or something, and you can also assign your elastic IP for your network load balancer. Okay, so as I said, network load balancer used for extreme high power TCP and UDP traffic. So, and the main thing is it is not included in the AWS free type. So we are not using this, but it is similar to something like AWS application load balancer only. So instead of here creating a web request, here we will define a TCP rules. Based on the TCP rules, it will go to your particular target group. So if it is port something like 4040, it will go to one target group. If you want 4050, that will be redirect to another target group. Okay, so remaining everything will be same. Okay, so the adding the target groups, adding the servers in the target groups, everything will be same. Only thing is the request which you are receiving will be changed. Okay, so before going that, so this is about the load balancer in AWS. So through this load balancer we can achieve scalability and high availability of your applications. Okay, so there are a couple of things you need to do. You need to remove all these instances after your practice. So yeah, I am stopping these instances and I am terminating these instances. So I'll terminate this, and other thing is I will go to my load balancer. I'll remove this particular load balancer. So if you remove the load balancer also, even if you remove the load balancer, the target group will not be deleted. Okay, so you can use this target group to multiple number of load balancers. So if you create 10 target load balancers, you can connect this particular target group to the 10 load balancers. So the target groups can be connected to multiple load balancers. So anyway, I'll also delete this. So if I open this and if I check this, see these two instances which I have created are terminated, so it is also removed from my target group. Okay, so I'll also remove my target group. So this cleanup process you need to do regularly, because like as we are using a free tier account, so we will not charge much if you delete like this. So I am deleting my application load balancer security group also. So see, it is saying that we cannot delete the security group because the security group is being used in other security group, because we have used this in this security group. Here we are using HTTP traffic to our servers from the security group. So what I'll do is I'll remove this and I'll say from any IPv4 address. So delete this and add a new rule, HTTP rule, and here I'll allow from anywhere. So save the rule. So now we can go to the security groups and we can remove this load balancer security group. So now it is not attached to any security group, so we can delete it. So that's it, we have cleaned it also. Okay, so in this class, just I'll give a summary. We have seen what is scalability and high availability, and we have seen how to achieve this using load balancers and target groups, and we also seen how to assign the load balancer security groups to our EC2 instance, so that we will allow only traffic to EC2 instance from the security groups only. Okay, so that's it for today. So if you have any doubts, you can ask me.